Okay, you're live. Let me send out some links real quick. I know where Discord ran off to. Okay. We'll send that. Okay, let's pop that out. Hopefully the audio is good. Okay, let me see if I can set this up in a way where I can still see the chat. Okay. So that I'm going to move it to the there. Try this camera. Hopefully the audio is okay. I had to mess around with this setup a little bit to try and get everything where I need it. So in this stream, I designed some test jigs and for my B data logger that I'm going to be releasing here soon. This was kind of the original test case, and then I've taken all of this and put it into this type of deal. Now this one is not finalized because I literally just put headers on this so that I could plug this board into it just to test it out and make sure everything works. One thing that doesn't work currently is that the FET on I want to be able to control the USB power to the, sorry about that, get the thing focusing. Let me take it out of autofocus here. Okay. So one thing I want to do with this thing is I can control, or I should be able to control when it powers on the actual board. So I can plug it in and it says board loaded, which is cool. And if I have USB power going from here to the board, like so, this cable is extremely long. Now, right now it's powering it up. I don't want it to do that by default. I want to be able to control turning the power on and off so that I can run a few tests, like check for shorts, check that the board's loaded, a couple other things, and then turn on the 5-volt power. The problem I'm having at this moment is that the FET that I have isn't the right one, doesn't work quite right. I've ordered hopefully the correct ones, and hopefully they'll be here tomorrow. But in the meantime, it still works. I just can't control the 5-volt output right now. The other thing I can do is I can turn off the 5-volt power and then see if it's being powered by the LiPo battery over here. So that's an option as well. So I'm gonna unplug that. Unplug that. Okay, so that is kind of like the first little test thing I did. Now obviously I'm not going to solder headers to this thing. Let me know if anybody's if you're watching, if the audio is okay. I hope it is. I kind of had to change some mic setup stuff, so if it's too loud or whatever, I might turn that down just a hair. Yeah, let me know. Anyways, I want to be able to, I can't solder headers to a board and then plug it into this and then ship it out, because by default they're going to ship without headers. You know, they're going to ship like this basically, right? And so I need to be able to put this into a test jig. So that one was just kind of a little, make sure the board itself works. Now I've got this set up, and what it allows me to do is, with pogo pins, load a board, and then I'll be able to clamp it down with a clamp that I just, there you go, misplaced. So it's going to be one of these numbers, right? So I still have to 3D print some stuff with this, but basically what I want to do is I'm going to solder on some of the other stuff, the button and the headers and things like that, and then we'll load that up on a Raspberry Pi, and then just see if that works. And then I can go over some like code and stuff that I've got. Okay, hey Carson, thanks for letting me know. Appreciate it. Let me actually I can turn on the chat now. So, I don't know. Give me 1 second. I wonder if I can turn on. Yeah, that kind of works. A little blown out, but trying to get all this stuff set up. All right, that'll have to do for now. Okay, so what I'm going to do is I'm going to do a little bit of soldering. So I'm going to unplug some of this stuff because I don't want to have us in the way right now. Set that over there. Try and solder this on stream. Mind me, I'm kind of rushed over here to get all this set up and going. So we'll set that there. So I've got this. Don't want to burn myself. Got this header here. I don't know why you can see that. That's going to go on the bottom of this here. And then that will plug into the Raspberry Pi. Again, try and do this without burning myself. Okay. And then I'm going to probably zoom out and see how messy my desk is. It is a mess. And I've got a fan here that sucks away all the solder smoke and whatnot. What the heck is that caught on? Okay. So that might zoom in a little more. So trying to do this away from everything's kind of a pain in the butt, but crank that. Oh, that is not the right one. Gotta turn the brightness up on this thing. There we go. Alright, so let's solder this on real quick. And I'm going to turn my head around because I don't want to bump my mic. I'm trying to solder this. And it's a little bit farther away from my face. It's a little hard, but it's the price you pay for recording it, I guess. Anything on there? Okay. And then I just want to make sure that that is sitting flush. Yeah, it looks pretty good. Right? Yeah. Just making sure I'm soldering it on the right side. That would not be good if I accidentally went back the other way. So yeah, this is 40 pin header, so this is a fun one to solder up. If I can. I've got some other stuff I'm working on. I need to 3D print some stuff for this. Doesn't mean I can't test it, but I got a fan, blower fan adapter I'm going to hook onto it so I can hopefully keep the Pi cool. Gonna have to see how bad this solder job is. Let's see if I can get this more focused. It's kind of hard to tell. Something like that, maybe. It's gonna have to do. Okay. that one. Okay. So yeah, this whole test jig thing, the B data logger board that I've designed, and I was just say I've already misplaced. It's quite complicated. It has a lot of features on it. It has a real-time clock built in, has an SD card slot, LiPo charging, voltage battery monitoring. You can check whether or not something is a USB device is plugged in. So there's a lot of stuff I have to test on every one to make sure it's good to go out the door, and that process can be kind of time consuming. With this test jig, it does it all automatically. Flashes the firmware, flashes test code, tests the entire board, and then puts on the shipping firmware, and it does it all in about, in fact, I've seen anywhere from 36 seconds to like 47 seconds, kind of depending, which is pretty fast. And I can have, you know, more than one of these too, so I can be doing like 2 boards at a time. Another really cool thing that I got working is, you know, let's say a board fails for some reason, like you know, the SD card slot's not working. I have a receipt printer that when it fails, I can print off on that receipt printer automatically what failed on it. I'll show you how that works in a little bit. But yeah, you can print it off. It'll say, you know, and it can tell me which test jig it failed on, what the fail was, what the board is, and then I can take a piece of tape and stick it to that board. And then that way, at some point in the future, if I want to try and rework some of these, because sometimes a rework is super simple, like if you just need to, you know, usually they're just like solder joints or slightly not fully connected. But I've noticed with a lot of my other products, like if I have some stuff fail, you know, I'll know what it failed for in that moment, but you know, a month from now, I might pick it up and be like, what did this fail for? I have no idea. So then I'd have to retest it again to see what the fail thing was. And this way, I can just look at, you know, what's taped to it with a little piece of Scotch tape, and it'll tell me, you know, hey, this board failed for this reason. So hopefully that'll make reworking them a little bit easier. There's some other stuff I kind of want to, I don't know if I'll do it or not, but I think it'd be really cool. It wouldn't be that difficult to log, like, to a database every board that I've tested, and then I can keep a history. So if I test a board and it fails, let's say for the SD card slot, it could save to the database, give that board basically like an identification number of some kind, and then so it fails, and then I fix that, and if I test it, and then if it failed for something else or some other reason, I could keep like a log history of what each board has gone through as far as being tested, which I think would be pretty cool. I don't know how useful that would be. I mean, it's not really something that, you know, somebody on the end user would probably care that much about, but just for keeping track of, you know, on my end, I think it'd be kind of cool, and it wouldn't be that hard to implement, really. You know, I could log it to a database on a website. I could do all sorts of cool stuff like that. So that would be neat. But like I said, that part's not working. But the printing off what fails, that does work. And I got one of those. I got a receipt printer, the same type that you see at, like, you know, McDonald's or Starbucks or whatever, where they, you know, go and it prints off real fast. I got one from Goodwill for like $30, and it works. So I can't complain with that. They're usually like a couple $100, I think. This might be a little more difficult. I'm going to turn this around. Hopefully the view is okay. These oh geez, solder joints are not exactly amazing, but I think somebody's up here. Oh, thanks, Carson. Yep, have a good sleep, man. I was in Germany, actually. I know you're probably leaving. I don't want to keep you up, but we were in Germany a couple weeks, or like 2 months ago. Had a lot of fun there. Beautiful country. But take care. So, yeah. Lots of cool stuff we can do with this. Try and get this soldered up quicker than less talking. That way we can get to the fun bit. Just, solder to stick. Solder joints are not pretty. Okay. So, yeah, I'm very excited about this because how I was testing boards before, I had it like a little bit automated, but it wasn't that automated. I built little test jigs, and they would have LEDs on them. In fact, I might have one over here. I can probably show you. This is kind of like what my old test jigs look like. And so I would, I'd load a board on it, and then I would load, and I built a Windows batch file or script that would load the test code or flash it, load the test code, then I would check and make sure all the GPIO worked by all these different pins, and then I would use the RGB LED on it, on the board itself, to give me a status update of whether or not certain features were working or not. And that worked okay. The biggest problem was the batch file wasn't super fast, about a minute maybe, but I had to manually input the COM port because I was doing it on Windows. So like every time every time you plug in a new different board, it would enumerate a different number, and then you'd have to type it in every time, to the point where like my COM port numbers were getting up to like the high hundreds. I don't think I ever got to 1,000. I don't know if there's a limit or not, but yeah, so that was a little tedious, and there were some other like little minor issues. And that was one thing where I could only do one at a time. So hopefully with this system, if I have 2 or more of these set up, I can plug or do multiple boards at a time, which should be nice and fast. You don't realize, like, when you're building products, like how time consuming it can be. Like designing them, that's the easy part, really. I have a pick and place machine now, so like that speeds things up a bit, but even using a pick and place machine, it still takes time. You got to build them, and then if you're going to support your products with good software, you have to write all the software. So like for my B data logger here, I've written a bunch of example codes in Arduino. Oh, geez, for myself. In Arduino and in Circuit Python, so that hopefully people can hit the ground running with it, and it won't be that hard. But that that's something that takes time. Then you got to test them all, and then you got to pack them all up, and so it definitely takes some time for sure. But I do enjoy it for the most part. Okay, we're getting close to having all these soldered up. Maybe poorly, but they'll be soldered. I'm not super impressed with this solder. And I think that one looks like it could use a little bit more. Jeez Louise. Okay, let's take a quick look at that. Alright, that doesn't look terrible. The other thing I want to do is I need to put in a pin header, and give me 1 second, let me grab a those and a key switch here, which you can't see. So a couple of these. I don't think I'm gonna need all those headers, but I grabbed a couple of them. Okay, so let's solder this one in first. And let's do that one. Try and keep that from, that could be a little pain in the butt. Let's see if I can, there we go. Okay. Hopefully, am I still in view? Looks like kind of am. Okay, let's make sure that's straight. Take that off. If I can get it off, come on. Let's maybe try and straighten this up a little bit. This needs to go. Okay. Just trying to straighten up the header so it's not as cocked. Okay. Yeah, let's get these in here. Okay. Alright, got those. And is that everything I need to manually solder? I think so. I'm not going to put the buzzer on just yet. Okay. Let's get that out of the way. Don't need that for now. Hopefully that was not loud in the mic. Okay, so now we need to put on a couple of SMD components here. I think that's as far as it's going to go. So I need a couple of USB ports. Technically I need a MOSFET just to make this work, but it's not the right one. Hopefully the correct one will be in tomorrow. It works in that the 5 volts flows through it fine, but I can't turn it off, which is a little bit annoying. Okay, got that. So those are 5.1s. Those are, I think those are 3.3. Let me just look at my, that's not the right one. Give me a second here. I need to open up my bomb list here. Okay, let's go here. Generate. Okay. And let's take this over here. Oops. Okay. That. Nope. So it's 10K. Okay. So 2 10Ks. 4 5. Try and do this without knocking anything over. So I don't have a stencil for this. I'm just kind of, I don't want to pay the extra money for the stencil when it's just a couple of components. Let's see, we got 10Ks. There's 1. It's 2. Again, don't know how well you can see that, but so this, I probably should have waited to put that one on, to be honest with you, now that I think about it, but I gotta heat this sucker up. And, oh, sorry about that. I kind of wonder if I can get better lighting over here. Okay, so I'm gonna put a couple of dabs of solder on that. Okay. Put these on. Now this is to knock the 5-volt voltage down. I got a lot on that one, jeez Louise. Hope I can take some of that off. And knock the 5-volt voltage down to under 3 so that I don't blow out the GPIO pins on the Raspberry Pi that I'm using. Okay, these are going to be 5.5 for the USB-C. Okay, grab a couple of 5.5s. That's 3. Okay. That. Get that anymore. Okay. Let's put these on here. Okay. And last one for that. Okay, and then I just realized I've got extra ones here of MOSFETs that I don't know what they are. Okay. We're getting there, almost. Thanks for your patience, guys. Let's get this stuff plugged in. Okay, got that. Let's put this MOSFET on, even though it's not the right one, but at least for now we can make it work. Okay. Go. And then USB-C here. This one's a tricky one just because, hopefully my head's not getting in the way. Because the pads are so small, you can get bridges which can make it not work. So I might have to rework this one slightly, but again, I didn't want to pay for the stencil for just a couple of these little boards. Okay, let's try and get some solder paste on these. Okay. That's not terrible. We'll see what happens. Okay, turn on our hot air gun. I apologize if you can hear the hot air, but it'll only be on for a minute. Let's see if I can turn this down. Otherwise I'm going to blow them all over the place. Actually, I wonder if I can do it like this. Try and not block the light. And not try and melt my connectors here. I really should have waited on. Let's put that up there. Alright, let that heat up. Definitely taking its time. Alright. I don't want to turn this up too fast because it's just going to blow them all over the place, but I'm also impatient. Come on. Why is that not melting it? Usually as soon as it starts melting, it should just, or reflowing, it should just suck up. There we go. There we go. Slowly. They're not going to be very pretty pads, just because, like I said, I don't have a stencil. I'm just going to blob it on there. But as long as it works, that's all I care about. This isn't something I'm selling here. Whoops. The solder is not flowing very well. Let's try this one over here. Solder might be getting a little old. Board's going to be super hot when I'm done. Okay. There we go. Yeah, stuff's flowing. There we go. Might not have it hot enough, I don't know. I don't want it to blow off. Alright, we're getting there. Get this one a little bit better. Okay, and do I have... Oh wait, no, I got a bunch right here. I need to put the battery connector on too while I'm at it. So put some paste on this. Okay. Why is that sticking to my tweezers? That's weird. Try this again. Okay. Alright, one more time with the air gun. Let's try and get this kind of blowing all over the place. Alright, how about we just melt this down first? This solder paste I have in this little syringe is probably pretty old at this point, so still kind of works, just doesn't reflow the greatest. Hey man. Some solder stuff. Not the prettiest. Okay. Oh, that gets hidden. If I can. Okay. Alright, that's probably good enough for now. Alright. So we got that. So let's let that cool off for a second, because that thing is probably super hot. I'll burn myself. And we can go back to this one for a moment. I'm gonna move some stuff around here. So, let me plug this in again. If I can get it on the right way. Where the heck did the charging cable go? There you go. Alright, well that was a fun adventure. Let's plug this in so I can kind of show you some stuff. So, is it on? It's on, okay. I'll let that charge up for a second. Or boot up rather. Let's come back here. Not that one. This one. Let's reload. Okay, so wait for it to connect SSH to it. What's up, Savage? Where do I get the pogo pins? You can buy them basically anywhere. I have a whole bunch of different types. You can get them from DigiKey, Mauser, Amazon, AliExpress. I'll quickly show you the different sets I've got. So I've got, this is just like one of my little boxes I've got going on. So these are like the ones that like slide through. They are like really difficult to find ones that work the way you'd want them to. Like I want pogo pins that you know, can seat in these little holes here and not slide through, like actually just seat in. And finding some that do that, the only ones that I've been able to find that actually do that are the ones that like slide all the way through the holes. But there's also, there's several different types. I've got a lot of the ones that like literally seat down into the, I'm going to turn on, maybe, manual autofocus. If I can get this to focus here. Got these will kind of mount into a hole and then have a spring on them. The focus is doing a terrible job. So, but yeah, you can basically buy them anywhere. Just try and find ones that work. Okay, back here. So this here is the first like revision of my code. I've not done a ton of Python stuff before. Like I've written lots of like little circuit Python and MicroPython stuff for some of my boards, but like just a full-on Python program. This is my first like real go at it, so this is kind of the gist of what's going on. But yeah, and I can consolidate a lot of this stuff, I think. But it's a lot of just typing stuff up and then see what you go. So let's documents, programs, Flash. I'm gonna start the program real quick. Okay. here. Okay, get this out of the way. And let's see if we can focus this so you guys can see what's going on. Okay, so if I unplug it, it says no board. It's no board loaded. With the other test jig, I won't have these. I'll just be able to set it on the pogo pins. But I'm just simulating that. So I plug it in. It says, "Hey, board's loaded. Press start." And weirdly, I think, yeah, the refresh rate on the camera is making it look weird on that little tiny screen. It looks fine in my life, but the refresh rate's weird. Anyways, hit start, starting test. I don't have like this text perfectly lined up on my little screen. Oh, and something failed. Let's see what it is. So these are the little printouts I was talking about, and that is blown out. Good Lord, can't see anything. Let me turn this way down. Maybe that's a little bit easier too. So it failed. It printed off this little test paper here. It says no USB, which makes sense because I don't have any USB hooked up to this thing. So let's do that and try it again. Got that. What do I do with my other one? Super long cable that I'm gonna have to buy a shorter one for. This is the only USB-C to USB-C cable that I have, and it's kind of a little long. Actually, I lied. I have one more, and it's like that long, which isn't long enough. Okay. The only thing I need to work out my code is when it fails. I wonder if I take this out, if it would. Okay, it says no board. Okay, that does work. Okay, so let's try it again. So we're gonna hit start, starting the test. Found the USB. Now it's flashing the firmware to it. Success. And then it's going to, yeah, it's putting the actual CircuitPython firmware on there, which is a file that it loads. Hey, thanks, Matt. It's very much a work in progress, but it more or less works. Then it's doing some testing. I don't know if I have a USB in there, okay. Or not a USB, an SD card. If I don't have an SD card, then it'll fail. So it's running through all that. Did it pass or did it fail? Yeah, test done. Took 49 seconds is what it says. So if anything fails in that process, as far as like, oh, yeah, hello. Yeah, so if anything fails in that process though, like, you know, the SD card reader's not working or the real-time clock's not working, you know, it'll print off this little note that says, hey, it failed for this reason, and then I can take a piece of scotch tape or whatever, stick it to the board, and that way when I go to rework it, I'll know what that board failed for. So, no worries, mate. Thanks for stopping by, though. Have a good day. So one of the interesting things that I found, like trying to figure out how to test everything that the board can do and how to read that in Python was a little bit tricky. I got it working. I don't know if it's like the best solution or not, but basically what I have it do is I have the board itself do all the tests, and then it prints to the serial monitor, or prints serial whether it's that component has passed or failed, and then I just read in my Python code on the Raspberry Pi whether or not that state is passed or what it's passed along. So, and it seems to work because I disabled different things and ran through the code and just to see if it would work or not. But yeah, this is kind of that code right here. So I open the serial port. I don't know if I can. Whoops, did I do the wrong one? Yeah, so I'll open the serial port, then I'll see if Wi-Fi pass is what's coming back over the serial monitor. I think this is the basic code. But yeah, and it seems to work, so I can test whether or not it can read that the USB is connected. You could extract the board's unique MAC address and store the test results electronically. Yeah, that's something I can look into for sure. Like I said, like I don't know if you're here now, like this is like my first like Python program that I've done, like, Circuit Python and MicroPython stuff for some of my boards, but this is the first like full on like Python thing I'm trying to work out. So I didn't know you could do that though. So like basically you can talk with the MAC address electronically. That seems pretty interesting. So yeah, I'll look into that. I don't know if that'd be better or not. Or if it'd be faster. But in any case, for our first pass for this, program, it seems to work, so that's better than nothing. But anyways, yeah, that's that. So let's go back to our back here. Rotate this around. Okay, so we've got our little. Let me disconnect this stuff. So yeah, so once I get the right MOSFET for this thing, because this one basically is just always on, I'll be able to test. I can basically disconnect the 5 volts and say, hey, are you still working even though you're on LiPo battery? And that way, that's one way I can test to make sure the LiPo circuitry on this is working correctly. So, okay, we got that. I'll unplug all this. Set this off to the side. Oh, that's interesting. Yeah, I'll look into that. If there's a simpler way to do it, I'm all for it. Believe me, there's a lot of like beating my head against the problem and coming up with a solution. It might not be the right one, but it seemed to work at least. But yeah, I'll definitely look into that, man. Thanks for the tip. So, but for the time being, I need to test some boards. So I gotta get this thing going. Okay, what was I doing? Hopefully that's. Oh yeah, I need to put on the key here so that I can press start on it. And I don't know if I should turn on the. I'm gonna turn on my kind of overhead light. This might be bright as hell, but it might make it easier to see. Yeah, that's fine. I was kind of worried it would blow everything out, but I think you can see much better now with that on. Okay, so I need to solder this on real quick. And I keep saying, oh, this is the last thing I need to solder, but I do think this is the last thing. Although I'm not 100% positive. Yeah, man, believe me, I've like watched every video he's put out as far as like how he's done his test jigs and stuff. A lot of useful information in there. He doesn't really share his code though, so, or at least not that I've come across. But yeah, I appreciate the tips. It's definitely somewhere to look. I didn't even know that was possible if it is. So, but anyways, yeah, have a good one, man. All right, let's get this soldered on real quick. Oh wait, I'm not trying to die over here. Plug my fan in. Later. All right. Come on. There we go. Let's see. No, it's not even remotely straight. Let's try and straighten this up a little bit. I might be doing this off camera, I apologize. I have to be able to kind of see what I'm looking at exactly. It's not always easy to do with the camera. That's pretty good. Okay. I appreciate it, man. I really do. I'll take a stab at it myself, and if I'm hitting like complete roadblock, then I'll let you know. Okay. All right. Get that. Okay, I think that's everything, and then I can put. Ooh. Make sure I get this the right way around. Put that on there. Okay, try to get this little screen out. That pops on there for now. I could solder it like directly into the board, but I guess it helps if you see that. I just plug this in basically. I put these on this side too. It's the same exact thing in case I wanted to try doing like these little smaller screens, which might make more sense, but I left the option. But right now I have the code set up for this thing, so I'm not gonna mess with it too much. Okay, so we got that. So right now I've got this kind of bolted onto the other one, so I'll need to take that apart. Pop that off. Okay, just give me a second here. I need to be able to see what I'm doing. I can turn that off because I don't need that going now. It's hard to remember to do this out, like my camera views like this way, so I have to like stick my hands like way out here for you to be able to see it. So I apologize if I do something off screen. I'm basically just unscrewing this so I can take the pipe off of it. And I need to come up with a kind of a semi-Morse, more permanent situation here. The other thing I was talking about earlier is I have somewhere blower fan. There it is. I've started designing a blower for this so that I can mount it like that on my, and it'll blow the cold air across the pie to hopefully cool it down, because they can get pretty toasty if you let them run for a while. Okay. Okay, take that off. Carefully unplug this without trying to bend anything. All right, got that one. And then I can plug on the new one here, even though it's the same exact thing, just with pogo pins this time. Okay, like so. Now, the thing I need to figure out is how do I want to mount this on the bottom, or the bottom of this thing, because I'm going to be applying pressure with the clamp like this, and while there's a base for the pie, it's kind of floating out in space here. So I'm thinking about taking another one and mounting it to the bottom, and then putting like standoffs between them. But then I have the exposed bottom of this thing, which I don't really want to do. So I kind of have, again, trying to find the stuff that I've got scattered all. I'm not going to show you my desk, but it's an absolute disaster. But I had, what in the heck did I do with that thing? There it is, found it. I found it. So this is like a metal bracket that you can barely see that goes on the bottom of pies. I'm using Raspberry Pi 3s because that's what I have on hand. I've had for a couple of years. I've got a couple of them. You know, as far as buying a Pi 4, you know, at the moment they're pretty much impossible to find. But there's a company, I forget what it's called, Neo something, that makes cases for Raspberry Pi 4s that would work really well for this case, but I don't have that luxury, unfortunately. So, might be able to do something like this. I'm just spitballing. I haven't really thought this out too far in advance. Let me take this back off. Just well, yeah, fuck. And then, so something like that. And then maybe mount one of these to the bottom of that through the through holes. That might work. That's a big can of might though. Let's try it. Might fail, I don't know. But we'll give it a shot. So I've got some, geez Louise, thermal paste. One sec. Got some pads of thermal paste, but I can't get the thing open. Those are literally just thermal pads. That's hilarious. So I've got like these pads of thermal pads that you would put on something like this. So we're just gonna eyeball it. Do this off screen for a second. I guess it could be a bit bigger, it doesn't really matter. How does that look? It's not too bad. Just put a piece of thermal pad on there. Hopefully that's thick enough too. Okay, so now we gotta get a little creative with which bolts and stuff I'm using. So this, yeah, try to do this on screen for you. Is that even making contact? No, it is not. Alright, let's try a thicker one. I got several different thickness pads here, but bear with, sorry. That, like that, okay. I am just going to stick that one directly on top. If I can remove the, okay. That's certainly one way to do it. So I've got a bunch of thick thermal pad on here that hopefully will stay. Okay. Let's see if this will get close to. Okay, that is touching. That's a good sign. And then my idea was literally just to sandwich this together like so. So let's see. I don't know if I have the right size length screws. This is going to be interesting. Try and get all these lined up. Sorry, I'm going to lift this up because I need to be able to see what I'm doing exactly. Okay, that one is not long enough. But I have a bunch of screws. So let's see what we got. Well, I should say I have a bunch of screws. I don't know if I have the right diameter ones though. Let's see if... Nope, that does not fit through that. What about this one? Nope. Dang. That's a problem. So those don't fit. Let me think about this for a second. So right now the problem is that that screw does not fit all the way through. I'm wondering, I'm trying to think, what can I do here? Are these longer? Oh, maybe. Oh, these gonna fit? Nope. Well, that's a problem. I'm trying to think how I can... I don't really have any connecting nuts. Let me look again. I do have a bunch of nuts and bolts here, so maybe something will... I can find something in here potentially. Gotta be pretty thin though. It's an empty bag. This is all just like random stuff. I don't even know if I have anything in here that would work. It's very much a hodgepodge of... I think those are the same ones, I think. No, let's just do that. I thought I had another thing of bolts. Well, I might need to buy some more nuts, unfortunately. I'm close to having something that would work, but it's not quite. No, don't do that. Don't do that. So that thing does not like to play well, right at all. Okay, well, I'm trying to think here. I might have to just buy the right size screws. Now that I think about it, because I don't know. I can't believe those are the only ones I have that are that diameter. Basically, all the other ones that I have are like slightly too big in diameter, so they don't fit through any of these holes, or the pie one. I thought I had more options than that, though. Okay, just drop that on the floor. Fantastic. That's not going to work either. That's a bummer. Well, take that off for now. Let's see here. Let's try something else for the time being for a moment. Is that going to be too big? Kind of looks like it. And sorry, I'm fumbling through this. So that one I had was too small. Yeah, I really need to have yeah, the problem, like the other size screws that I have don't fit through the pie one either. They all have to be whatever size these are, 2 mil maybe. Let's see. I just dropped it. Let's see, like what diameter this is. Yeah, 2.3 millimeter, something like that. So, all right, well, I'm not sure what I can do about that other than just order the right size screws. But, yeah, okay. So in any case, I'll have to figure something out for the mounting on the bottom here. I suppose I could plug in. Why don't we just do that? Let's test a couple things on this. I'll plug that in. Let's plug the Ethernet in. Let's plug the USB power in. Hopefully these don't break off. And hopefully the connections are good enough. And then let's plug in the Pi. Get this plugged in the right way. Okay, it's starting up. And then we can kind of just test this board and see if everything's connected correctly. In fact, I wonder if this is, it should. I don't even know if I've tested this this little board by itself. Give it a second for this to boot up. Because it needs to reload so I can log back in. Reload, please. Okay, so we need documents, programs, flash, whoops. Okay. So it's not seeing a board, which is correct because I don't have a board in there. Let's see if this thing will survive. You might see some like flickering on here. It's because probably the frame rate of this thing and the camera is different. So let's just stick this on and see if it notices the board. Oh, I did it there for a second. Huh, interesting. Something's not. Okay, so that says board loaded. I'm gonna have to redesign. How did I not notice that? I'm gonna have to redesign this thing, I think, if I can get it out. Because, yeah, it is. Huh. So I made a cutout for the, for the on-off switch, right? For the board, so I can sit here, but it's not quite deep enough, so the board doesn't sit perfectly flush in that. So I'm gonna have to redesign and reprint that, which is fine. I guess that's part of this process. Because I don't think I can cut that out or anything. But in any case, I did detect the board. Let it focus on that. I don't know if, yeah, so the battery part worked because it turned on. So this will be interesting. Let's plug in, I'm going to plug in the USB. Since a couple of those pins, I don't think they're seating properly. If I start the run, or the code, whatever you want to call it, test code, it's probably going to fail for maybe like a 3.3 volt or something not being connected, I'm guessing. Okay, that powered up, so let's, nope, did not like that. Might have a short or something. Huh. Or I didn't have it seated on there, right? Okay, yeah, I think I just didn't have it seated quite right. So it says it detects a board. I'm gonna hit start, starting the test. And let's see what fails. If it doesn't have an SD card in there, so it'll fail for that. I found the USB, that's a good sign. It means our USBs that I just put on this test board work correctly. It's taking forever to... What does it do after USB found? I have a feeling, oh, I know what it's doing. Okay, so I'm gonna have to adjust the code a little bit because right now basically I have it detect if it can detect the USB, like, hey, are you seeing the board? If so, then I check all the voltages. So the 5 volt, 3.3 volt, 3.3, the second LDO voltage. Oh, there it goes. Did it do it? Took its sweet time. I might not have just had a good enough connection for it to detect the second LDO, because that's the corner that's kind of raised up here. It says it's flashing the firmware, but I don't know. This seems sus. Because I don't think I have a good enough connection on any of these pins. Okay, let's stop it. Yeah, I think there's just a connection issue because I can't get it to sit flat with the on-off switch. So I'll have to adjust that little cutout. It kind of works. Let's close that. Oh, there we go. Let's go back to the main desktop here. What's going on? It's my wife. And she's sending me memes. Okay. Let's look at the code real quick. I'm just curious. Let me see if I can find. So here I have it going to, if it finds the USB,
Okay, true. If okay does equal true, then I pull, I flash. How am I doing the? How am I doing the? I don't know. Okay, I'm doing the voltage checks before the USB. So something maybe was up with the USB. I don't know. I'll have to look into that. I'm gonna have to. Oh, you know what we can do? I'm an idiot. Why don't we just test it without this in there? I don't have to have this on there. So I'm gonna restart it. Oh, didn't like that because it thinks it has a short. Stop. Oops. Okay. No. Keep lifting a pin. Right, although it is saying a short's detected. That's weird. Maybe. Do I have a short? Nah. Cancel that. So it should. Let's do this. Let's unplug that. There's a lot of stuff you have to work through when you designing things. Okay. It says no board. We can all agree on that. I'll plug this in. Okay. The board is loaded. Plug that in. I hit start. I'm holding everything down. Starting test. USB found. Okay. So I probably just didn't have a very good connection with the. Although it just aired. Okay, that's the problem. So, since I've manually put the little solder on these USB connectors, one of the data lines is connected. Because on my computer over here on the terminal, it said there's an error that it throws when I know that it can't find the USB via the data lines. So I'll have to rework those. Probably not right this second, but. In any case, yeah, making progress on this thing. Hopefully this weekend I'll 3D print some stuff. I can show you real quick what I'm working on. As far as like the, I think I still have it open. Let's see. Yeah, here we go. So I've got this 3D mount fan, right? And I'm just kind of working out some of the stuff on it. 3D printing it's going to be interesting because I'm not really sure best orientation for it, but the idea is it'll blow air out to this hole here. Then that'll blow across the 3D or the Raspberry Pi. So yeah, and then I need to 3D mount or 3D print a mount here for the clamp so that I can clamp that down. So that's coming. I like how I got my little board in here. Correct dimensions and everything. Yeah, and the other thing I'm gonna have to fix is this here. So which body is that one? I can't remember which one that is. Not that. That one. Okay. Let's open that back up. Oop, not that one. Turn that off. Somehow. This is not, I'm not the best when it comes to like constraining stuff. So, if you're one of those people, I'm sorry. Just do things as quickly as possible. Let's just make this nice and small like that. So that should give plenty of room to that switch now. Save that. Hopefully the frame rate's all right. Keep getting an alert from YouTube that's like, hey, your bit rate's not high enough, but okay. Turn those back on, turn that back on, turn that back on. So yeah, I'll have to 3D print that. Yeah, so this here is kind of the test jig and the board, and then I can design my models or
mounts and stuff. So I've got that one. And designing this one. Oh yeah, okay, well, I can't really do a whole lot more until I rework that and get the right size screws, which I'll order tonight. Hopefully they'll be here this weekend. I don't know if they will or not. And I'm waiting on the correct MOSFET so that I can control the 5-volt power. So there's still some stuff I need to tweak and get the right components and 3D print some more stuff. I don't know if I'll stream any of that this weekend. I might. We'll see. But it's coming along. Like, I'm happy that, like, even just like in the basic sense it works. I can plug a board in when it's working right, at least. Put a board in, hit the button, it flashes it, puts the code on there, tests the board, puts the shipping firmware on it with test results, and it's done. And it takes like 40 to, yeah, around 45 to 50 seconds. Although I have seen it do it a lot quicker, so I don't know. I've seen it do it in 36 seconds. So I don't know if it's just like dependent on boards or what else, but now how am I planning to test the IC ports? So that's an interesting one because there's not a great way to test those other than what I've done in the past is just take a sensor with on the stemma connector. I don't even know if I have any laying around here. I've got a bunch of. Anyways, I usually have just taken a stemma connector with on the sensor board and then plugged it into the port and make sure it turns on and it's functioning. It's not the most efficient way to do that, but I can't think of any other way that you would test it. Another thing I've learned just from doing that is like it's pretty rare that they don't work. As long as you take a look at it and they, they're in the correct position on the board and they're soldered, they're just like a connector, So something would have to be seriously wrong for it not to work. That's how I've done it in the past. And that's probably what I'll do, because I'm kind of anal about that. Like, I do want to test everything. So like before I put them in like a bag, to say like, okay, it's in a static what's the right word? Electromagnetic static bag, anti-static bag. Before I put it into one of those, I'll test. I'll plug a stemma connector into it, make sure it still works or turns on at least. But yeah, that's about the only way to do it. There's no real way to automate that, unfortunately, because it's just an actual connector. The same thing kind of applies to the battery connector, because that's kind of what I was doing before. I'll go down here real quick. So like I can test that the battery circuitry works automatically because I have this here and it'll go to one of the pins which is connected to the battery. So I can test that all that works. But the only way to test the actual ports is to actually just plug something in. And I can promise you, like most, like Adafruit and, I think Unexpected Maker, I don't think he tests them either. It's just one of those things, like after you have manually tested them enough, you realize that like it's extremely rare for them not to work, as long as their solder joints are right. So as long as they're in the correct position on the board, they should just work. But yeah, that's a good question. I mean, in the past I have tested them all. I plug them all in and let them go. But at a certain point, I guess you do that long enough and you have 0 failures. You're like, okay, well there's the odds of having a failure is pretty slim. So I think at that point you probably just kind of like, I don't know if chance it's the right word, but you'll deal with the failure if it happens. Like it's a cost time benefit analysis kind of a thing, Is it worth your time to test all those connectors when you might have a failure 1 out of 1,000 times? You know what I mean? And if it does happen that 1,000 time, well, you take care of the customer, you make sure they get a replacement or whatever, and go from there. So yeah, it's one of those things. Okay. Well, thanks for everybody that stopped out tonight. Had a good turnout, and appreciate everybody chiming in, saying hi. So, yeah, in any case, got a few things I got to sort out, and then we'll get this thing on the road. And Matt had some pretty interesting ideas as far as using the MAC address of the board to electronically get the results and stuff instead of doing the serial monitor stuff that I'm doing, which works, but it may not be the most efficient. I don't know. So I will look into that. But anyways, I am going to head out. Thank you guys for tuning in. And I will see you in the next live stream or video or whatever. So stay tuned. Thanks for watching. Bye.